500 to 370 BC. Greek philosophers like Anaxagoras and Leucippus believed that all matter was made of atoms, and that all things were infinitely divisible. And Plato believed that there were only four elements: fire, water, earth, and wind. John Dalton, 1803. He proposed that compounds were made of two or more elements, and that chemical reactions were just the rearrangement of atoms. He also proposed the law of multiple proportions, which said that elements combined in ratios of small whole numbers. The periodic table of the elements in the 1800s. John Dalton composed the original periodic table of the elements, which was based on the relative weight of the elements. John Newland placed them in groups of 8, which eventually led to the octet law of chemical bonding. Dmitri Mendeleev based them on 3 things: patterns of properties, relationship to other elements, and atomic weight. J.J. Thomson, 1903. His cathode ray experiment led to the discovery of electrons as subatomic particles. This also concluded that negative charges cannot be separated from positive charges. He also constructed the plum pudding model, which was a positive field with negatives diffused throughout. Ernest Rutherford, 1911. He conducted the gold foil experiment, by which he concluded that the atom must consist of a dense, positively charged central region containing most of the atomic mass. He also identified helium nuclei as alpha particles. He also discovered alpha and beta rays, which supported his theory of radioactive decay. The dawn of the 20th century, Millikan and Becquerel. Millikan discovered that a single electron is equal to 1.602 times 10 to the negative 19th coulombs. Becquerel discovered radioactivity in 1896 with the use of uranium. He also concluded the penetration capacities of alpha, beta, and gamma rays. Niels Bohr, 1913. He constructed the Bohr model of the atom, in which electrons stayed in a stationary orbit. He concluded that when electrons jumped shells from high to low, they emitted light, and when they jumped from low to high, they absorbed energy. Finally, he deduced that when electrons jumped, they released radiation. Schrödinger, 1920. In his model of the atom, he abandoned precise orbits for electrons. His partner Heisenberg created the uncertainty principle, which states that you cannot know the position and the momentum of a particle at the same time. Schrödinger also developed probability functions to find where an electron could be found in orbit around the nucleus.